All right, in this video, we're going to go ahead and take a look at how to go ahead and use what we've done in the previous videos with this unit circle right here and the definitions that we discovered to fill in this chart right here. Okay, so it's going to take a little bit of work, but after we put all the pieces together, hopefully we can see why this works so nicely. Okay, so the first thing that we want to do is that I want to fill out the radians column. And the radians column is going to be right here. So that means is that all the degrees that we have right here correspond to a particular radian. All right, and so I want to get those filled in right here so we can have the degrees matching the number of radians. So let's go ahead and do that. Okay, and again, the way that we got those is from our unit circle. 0 radians is 0 degrees, 30 degrees is pi over 6 radians, 120 degrees is 2 pi over 3 radians, etc., etc. So we're just filling this on in. So this next concept that we're going to take a look at is a reference angle. And a reference angle basically means is that, say if I go to 60 degrees right here, okay, the reference angle is always going to be the angle that make with the closest x-axis. So in this case, it would be 60 degrees, okay? Now, it seems like, oh, well, of course you went 60 degrees, but say you went 210 degrees over here. Your reference angle would be 30 degrees because it is going to be the degree measure that you make with the closest x-axis. And we have to go ahead and also recognize that these right here, the axes, the y-axis and the x-axis, we can't make triangles with the x-axis with that because there's no way to make the triangle either way. And so those don't have a reference angle, okay? So that said is that I'm going to fill out the reference angles right down here. And we're not going to use them per se in this video, but they're going to be super important in the next videos when we start to put things together. So I wanted to introduce them here. So here's what they look like. Okay, so there's all the reference angles done out. And what we're going to do now is that we're going to start tackling the sine, cosine, and tangent, and then the reciprocals. So let's concentrate on sine right now. So here's the sine column, and sine's definition that we learned from the last video is that it's going to be y over 1. So if I were to take the sine of 0 degrees right here, it would just be 0 because it's going to be the y value of those points that we discovered. The sine of 30 degrees would be 1/2. The sine of 150 degrees would be 1/2. The sine of 240 degrees would be the negative square root of 3 over 2. So we can see why all of these values are going to be super important on the unit circle because it allows us to define sine, cosine, and whatnot as we go all the way around. Now we're just concentrating on sine, but anyhow, this is what it's going to look like. And you notice that as we go around the unit circle, okay, it's just going to be all of these y values right here and going around in this fashion, etc., etc. So here's what they look like on the chart. Okay, so there they are. And we're going to go ahead and next work on cosine, which is just going to be the x values. So again, the cosine of 0 is going to give me 1. The cosine of 60 degrees is going to give me 1/2. The cosine of 300 degrees is going to give me 1/2. The cosine of 225 degrees is going to give me a negative root 2 over 2, etc. So no matter where I look on the unit circle, wherever that the terminal side stops, the x value that it points to is going to be the cosine of that. Okay, so this is what that's going to look like. Okay, so there is the cosine row, or I should say the cosine column, done all the way out. Okay, so next, and there's going to be a little bit of a sad face here because we got tangent, and tangent's going to require a little bit of work for us because it's y over x, so we have some division to do. But I'm going to show you some quality of life tricks to go ahead and get these pretty easy. So let's go ahead and set this up for tangent, at least going from 0 to 90, and then see where this goes. Okay, so here we have tangent going from 0 to 90, and what I want to do is just introduce how we're going to set this thing up. So we got to go ahead and by definition go y over x. Okay, so the y value is going to be basically y value is here, and we're going to have to put it over x. So we're going to get 0 over 1, which is a 0. And so that's not that difficult. However, when we compound fractions out for the tangent of 30 degrees, this is what that's going to look like. So the y value is going to be, for 30 degrees for tangent, going right here, okay, is going to be 1/2 divided by the square root of 3 over 2. And so when you're dividing fractions, you go ahead and you take the first fraction, and then you multiply the reciprocal of the denominator, okay, which is going to be this guy. Those are going to cancel out. And so we're going to get 1 over the square root of 3. However, we have to go ahead and multiply the top and the bottom by the square root of 3 to rationalize the denominator. And so we're going to get the square root of 3 over 3, okay? So I'm going to clean this up real quick so we can go on. The tangent of 45 degrees is going to be root 2 over 2 divided by root 2 over 2. And we know that anything divided by itself is going to give us 1. And for the tangent of 60 degrees, which is going to be, so this is the 45 degree guy that we just got done with. And then so the tangent of 60 degrees is going to be right here. And so we'll have the square root of 3 over 2 divided by 1/2. So we get the square root of 3 over 2 multiplied by the reciprocal, which is going to be 2 over 1. Those will cancel out, and we end up with the square root of 3. Okay. And then finally, for 90 degrees, we have something that first time that we're going to see with these trigonometric ratios is that we have 1 over 0, which is going to be right here. Okay. So that said, is that we got to remember that anything divided by 0 is not going to go ahead and be good news, and so we know that this is going to be undefined. So that said, is that these values that we just discovered right here, so pardon me, this, and this are going to go ahead and all be in some way, shape, or form the numbers, whether they be positive or negative, for the tangent column as we go around the unit circle and we keep doing the y divided by x. Okay, so we got to remember also when we're dividing with the tangent out is that a negative divided by a positive, or a positive divided by negative, is going to give us a negative. And for these guys right here, a negative divided by negative is going to be positive. So remember our sign rules as we go ahead and we march around the unit circle for tangent. So this is what the tangent column is going to look like. Okay, so there it is, all pretty much laid out. Okay, and so what we're going to do next is that I'm going to introduce how to deal with the reciprocal functions. Okay, and so the reciprocal functions are going to be cosecant for sine. Okay, so that means is that we take what it equals to, which is going to be y over 1, and change it to 1 over y. So basically we're just flip-flopping the value of sine. And so, and you notice that the same holds true for cosine and secant, as well as tangent and cotangent. So I'm going to show you how to tackle cosecant, and then you can apply the rest the same technique to the rest of the particular reciprocal identities. So let's take a look at what sine equals straight across and how to deal with taking the reciprocal of it. Okay, so since we know that these are reciprocals of one another, that is sine and cosecant, what we're looking at then is taking these values, taking the reciprocal of them, and putting them right here to evaluate them out. So let's go ahead and take a look. The reciprocal of 0 is going to go ahead and be 1 over 0. Well, and division by 0, as we learned with tangent, is going to give us undefined. Okay. This guy right here, we take the reciprocal of 1 over 2, and we get 2 over 1, which is just 2. This guy is going to require a little bit more work, as we take the reciprocal of square root of 2 divided by 2, and that's going to give us 2 divided by the square root of 2. We need to rationalize the denominator by multiplying the top and the bottom by the square root of 2, and we get 2 square root of 2 all over 2, which those cancel out, and we get the square root of 2. This guy right here, we take the reciprocal of square root of 3 divided by 2, and we get 2 divided by the square root of 3. Multiply the top and the bottom by the square root of 3, and we're going to get 2 times the square root of 3 all over square root of 3 times square root of 3 is 3. And then finally, we got 1. The reciprocal of 1 is 1 over 1, which is this 1. Okay? And really, that's the way that you do each one of these. So you're taking the reciprocal of sine and putting it right here. Reciprocal of cosine, and you're putting it right here. And the reciprocal of tangent and putting it right here. Okay, so I'll let you go ahead and do those columns, and here is the result that you want to check your work against. Okay, so there it is, and in the next part, I'm going to go ahead and make a larger version of this entire chart right here so we can see it better. And we're going to take a look at noticing some of the patterns and whatnot in regards to the unit circle here, and then move on over into some shortcuts to evaluating these, because sadly enough, we have to go ahead and be responsible for this entire chart and understanding it. Okay, without a note card eventually. So I'm going to get going in that direction. So yeah, I will see you in that next video.